All right. So we're gonna do this centripetal motion worksheet here. Pretty simple stuff that we're gonna be doing today. So centripetal force. The equation for that is the mass of the object times v squared over r. Centripetal acceleration is v squared over r. They ask you for tangential speed, linear speed, tangential velocity, linear velocity. They're asking for v. In which case the equation is 2 pi r over t, or it could be velocity is equal to 2 pi r times f, depending upon what is given. So the first thing, all right, you have a 3.4 kilogram bucket of water that is attached to a 1 meter rope. This bucket is swung around in a circle at 10 meters per second. They want to know what the centripetal force is on the bucket to keep it moving on its circular path. All right, so you have a mass, you have a radius, and you have a velocity. So to solve for centripetal force, your equation, you're only squaring velocity, so you're going to have 3.4 times 10 squared over the radius, which is 1. So 10 squared is 100. 100 times 3.4 will come out to be 340. Divided by 1 is just still 340. So from the PowerPoint, from the notes, guys, we should know what the unit is for the force. Centripetal force, just like all of our others, it's newtons. Okay. So what's going on in this one too? If the centripetal force on an object is 100 newtons, if the speed of that object moving in a circular path triples, what would the centripetal force become? Okay. Well, we don't know what the mass is. We don't know what the radius is. What the heck is going on? So when you come across problems like this is a proportionality kind of problem. And for when you get those, I always tell you guys to use the ones equation. So you have the centripetal force is it's m, it's v squared, it's over r. So when we do this, we make everybody in the equation a 1. All right, so the centripetal force is a 1. It's equal to whatever the mass of the object is originally times whatever the velocity is originally, but the velocity is squared, divided by whatever the heck the radius is. So what did they tell us? The speed triples. So speed is velocity, right, is the v in the equation. So if v is no longer a 1, we have to make it a 3. Nothing else in the problem changes. So the mass stays a 1. The radius stays a 1. So mass stays a 1. The velocity, though, triples, and you have to square it in the equation. The radius doesn't change. So what's 3 squared? 9. 9 times 1 is 9. 9 divided by 1 is still, it would be 9 times the force. So if the original force is 100, be 9 times 100, which is a grand total of 900 newtons. Bam. Wah, wah. Okay. In letter B, they're asking, okay, well, if the radius of the circular path is now doubled, what would happen to the force? So the same thing. They don't have like a bunch of extra numbers. They're just telling us that something is doubled or tripled. In those cases, you set the problem or the actual formula in question to the ones equation. So it's the same thing, same concept. Did it say anything about changing the mass? Nope. So it stays a 1. Anything in part B about changing the velocity? Nope. So that stays a 1. They did say something, though, about changing the radius, and the radius is on bottom. The radius is doubled. So 1 squared is 1. 1 times 1 is 1. And 2 is just here. So it's going to be 1/2 f when you simplify this, right? 1 squared is 1. 1 times 1 is 1. 2 just carries over. So it's 1/2 of the original force. Our original force was 100. So half of 100 becomes
50.
50 newtons. Bam. All right, now I know this isn't on there, but I want to see how would we do it? Let's say, what if we doubled the velocity? Double the velocity, but also the radius. You don't have to write this down, but I just want to just work another problem out. So if we double the velocity and radius, so originally, right, mass times velocity squared over the radius. If we double the velocity, mass doesn't change. Velocity become a 2. We have to square the 2. And then divide that by the radius, which is now doubled. 2 squared is 4. 4 times 1 is 4. Divided over here by 2. 4 over 2 is, so it would be 2 times f. 2 times 100 would be 200 if you got a problem like that. Okay. So in number 3, all right, well, sorry, these guys all go with this like made up part here. So this isn't part of actual number 3. They want you to find the centripetal force on the object. Okay. So you have your equation for centripetal force. You have mass, you have radius, you have velocity. You're going to put them into the correct positions. Mass was 1. Velocity was 3, and you have to square only velocity. Then divide out by the radius of 0.25. Once you've done that, all right, let's see. What's 3 squared is 9. 9 times 1 is 9. All right, and then you divide it by 0.25. That's like multiplying it by 4, which should give us 36 newtons as our centripetal force. Okay. Well, now they want you to still find centripetal force for B, C, and D. So what you want to make sure you do is label who is what. Kilograms is mass. This meter here is your radius. And this meters per second is velocity. So you guys are going to wind up going through and you guys are going to wind up solving those guys there. And then on part E and F, they also want you to solve for centripetal force. You should be able to figure out which one's the mass, which one's the radius, which one is the velocity. And then for part G, it wants you to rank them from the smallest centripetal force to the largest. So you would put them like A through F. All right, like if C wound up being the biggest, C would go first. If then A was next, it would be like, so you would have it like C, A. Who knows what the heck the next one could be? Could be E, etc. Until you finish the end. And if there's two of them that are the same, let's just say like C and D were the same, or how about F and D? If F and D were the same, and B was the smallest, it would look something like that. So you guys are going to complete those problems on your own. Number 4, 5, and 6 want you to solve for centripetal acceleration. So that equation is on the front of your worksheet, which is v squared over r. So acceleration is v squared over r. So the dog sits 1.5 meters from the center. That's your r. And it has a velocity or speed here of 1.5. That's v. So it'll be 1.5 squared over 1.5. The next one, it moves at a speed of 11 and it has a radius of 0.5. What is the centripetal acceleration? And then the last one, this radius is 48 meters and it has a velocity of 20. So that's v, that's r. Find centripetal acceleration. All right, so that's what you guys are going to be working on. And when you guys complete this, please make sure that if you're not doing the work on the Google Doc, if you're doing it on a separate sheet of paper, or if you printed it out and you're working on it like that, make sure, again, you do take a picture of that and attach it to and submit your assignment. Okay, so that is your homework that you guys are going to wind up starting now.
Mr. Lombardo?
Yes. Give me one second.
What's the unit? I was about to ask what that was.
Yep. Okay, so the unit for centripetal acceleration is meters per second squared. Good question. And then the rest of you guys should be able to easily crank out, okay?